Hi everyone, Lloyd Rieber here to show you the second prototype of a physics app I have built. Now, before I get started, let me just explain that this app tries to show you the relationship between acceleration, velocity, and distance. Now, the purpose of this video is not to teach you about those relationships, but to show you how the app works. And if you choose to then play the app, well, then you might actually learn something about those relationships. Now, you might think you already know everything there is to know about acceleration, velocity, and distance. Maybe you're wondering where the word speed comes into play. Well, we use these terms a lot in everyday language, but it's really a little more complicated than that, and I think a lot more interesting than what we tend to think of these ideas. Okay, let me show you first how the simulation works, then I'll show you how the game works. Okay, I'll click on my choice of simulation only. And it gives me some directions. And I think that is really important to note that all I control here is the acceleration by clicking either the up or down buttons here, these red up and down buttons. Okay, let's begin. All right, here we go. Well, what's happening? Well, we have a graph, and it seems like everything is set to 0. So acceleration is 0, velocity is 0, and distance is 0. Got a little marble over here. It doesn't seem to be moving. Well, let's hit one of these buttons and see what happens. Let me go up. Well, I am now accelerating toward the top. And as I do so, I see that the marble over here is going faster and faster, and it goes off the edge. Yikes. So I need to somehow control that marble so it stays on that little yellow surface. So let's restart. Try this again. All right, let me go and accelerate toward the top. And now let me go ahead and hit the down button. And I can see that that marble is going now at a constant speed or rate of velocity toward the top. And that those two things, the speed and the direction, are what define velocity. So I hit the down acceleration. Now it's going faster and faster. Let me hit the up button. And you can see I have to be pretty mindful here of that marble over here on the right hand side. But the marble and the blue graph are exactly synced up. So let me try to get that marble to go a little bit on the slow side at a steady rate. And I do know a little something about the relationship between these three things. Here we go. And so yeah, so I have these three graphs right now, and you can see the solid red line has been mirroring my pressing of the buttons. We have this dotted green line, which has been the velocity, and you notice that right now the velocity is a constant. The distance that the ball has traveled is this blue line, and you can see that it's going, in this case, at a constant rate, but it's not increasing, it's not decreasing, but it is definitely moving in the upward direction. And I finish the round there, and I get a nice little ta-da. And I'm getting close to the top there, so let me accelerate a little bit now toward the bottom. And I'll quickly go back to an acceleration of 0 so that I don't have the acceleration kind of getting out of my control. So you get a little sense here of these three graphs and how they work together. Now you can turn the graphs on and off. So I can turn off that acceleration graph if I want to, just like the velocity graph, the distance graph, or I can also just turn off the marble, the image of the marble, or I can turn off everything, which is not something I recommend because you might not know what's happening. So let me turn everything back on here, or maybe just turn on the ones you think are the most important. But those graphs I think are really important to understand these relationships between these three principles. Okay, so I'm doing great here. Another ta-da. So let's go ahead now, and I'm going to restart this, and now I'm going to show you how the game works. All right, so maybe you found that simulation to be really compelling, and you just want to play it all day long, but most people find it a little boring after a little while, unless you're a physics geek like me. But even if you are a physics geek, you might like a little bit of challenge. So I have invented a game that I'm calling Thread the Needle. So let me go ahead and play the game to show you how it works. And there are some directions here. And let me just go ahead and play it so you kind of see what's happening. Now you can see right away there's something different. There is a target, and that is going to be worth 40 points if I can thread the needle, which this is considered the eye of the needle, and that blue distance graph is going to be the thread. So here we go. So if I don't do anything, it's obvious I'm going to miss the target. So I'm going to hit the down arrow of acceleration to start accelerating toward the bottom. Nice little ding there, but I need to move back up to try to get the next target. And you'll see that my maneuvers, every time I press the acceleration, ooh, I just missed it there. So I'm not paying attention. Every time I press one of those red arrow buttons, I am going to be charged, so to speak, with a maneuver. And if I don't get to the target, I hear a little oops, and it moves to the right. I think I can get this one. I have to be careful not to go off the edge. Ah, there we go. There we go. Now let me try to pay attention here and try to get that 40 points. And I don't know if I'm going to get it. I'm going to maybe just be able to thread it. There we go. Oh, I just got lucky. If I just kind of let everything go and not press anything, I should be fine. So you can see how the blue graph is like the thread. I'm trying to thread the needle. All right, so I'm going to get those 60 points. All right, and I get the round over. So yeah, what are my points here? Well, you can see I have a total number of points of 160. That shows up there. 16 maneuvers, but it actually says there I lose 5 points for every maneuver. So 16 times 5 is 80. But I also get 100 points for finishing the graph or finishing the round. So 160 minus 80 plus 100 is 180. And that is my score. So I hope you can see how this little game, Thread the Needle, really adds some challenge and a goal to this exploration of acceleration, velocity, and distance. So as you're playing the game, let me just show you one more thing, and that is if you want either a greater challenge or a less of a challenge, you can make some changes here. Now it actually starts, the game starts, I think, with the easiest set of conditions. So what I can do though is, for example, change the horizontal step size to something a little larger, and I'll leave the acceleration alone for right now. Let's play the game again to see what happens. So here we go. Let's begin. Whoa, it's really moving now. So you can see that whoops, I have to really pay attention. I didn't do so well. So you might want a greater challenge, or maybe you don't. So you click here to continue. And if you ever get to a point where you say, "Whoa, I really changed things around," I can always reset to the default. So it's just a nice way to change the some of the conditions of the simulation or the game in order to explore this in a little bit more depth or with a bit more of a challenge. Well, I hope that gives you a good idea of how this little physics app works. If you'd like to download it and try it for yourself, you can go ahead and do so by going to my blog at learninglivecode.blogspot.com and check it out for yourself.